Hi guys, today we're going to do grade 9 exponents. We're just going to quickly run through the laws for you guys. The first law is when you multiply two like bases, you add the exponents. How does that look? If I have x to the power 3 times x to the power 2, that would now give me x to the power 5. But that also means x to the power 5 can be written as x to the power 3 times x to the power 2. Now in your second law, when you divide in like bases, you can subtract the exponent. So if I have, for example, let's now use an actual number, 2 to the power 3 over 2 to the power 2, that will just equal 2 to the power 3 minus 2. And that will just equal 2. Now you can even go and put this in your calculator. See, this will just be 8 over 4, and that just equals 2. Onto our third law, and that's when you have a power of a power, that's when you multiply them. So if I have x to the power 3, then to the power 2, that now will equal x to the power 6. We're just running through these laws so you understand them, so when you're doing the examples, you know what's going on. On to law 4, this is a bit of a distributive. So if I have x to the power 3 in brackets times y to the power 2, and that's all to the power 3, that will then give me x to the power 9 times y to the power 6. Now when you have a fraction and it's to the power, you're going to multiply the denominator and numerator by that power. So if I have, let's say, 2 to the power 3 over, let's say, 3 to the power 2, and all of that is to the power 2, that will then give me 2 to the power 6 over 3 to the power 4, because I multiplied. So let's go on to some of these questions. You guys are more than welcome with these questions to go and try them out first and then look at the answers afterwards. So we're going to start off with this number 2, and we just have a power of a power that is just going to give us equal to x to the negative 10. Moving on to number 3, we have a power of a power, so we can do number 3 here. So we're going to multiply that negative 2 by negative 2, and that's going to equal x to the power 4. Let's do 5 here. And now 5, we're going to be applying this property where we multiply each of the terms by the exponent on the outside. So I'm going to have negative 2 to the power 4 times x to the power 12. Now if you go into your calculator and you put negative 2 to the power 4, you'll see you'll get 16 there, and it'll be a positive 16, and you get x to the power 12. Let's move on to number 6 right here, and we're going to apply the same rule again. So we're going to go to number 6. Here we have, it's just going to be x to the power 8 plus x to the power 8. Now these are two like terms, you can then add them together, so it'll be 2x to the power 8. I know a lot of you, if you are struggling with this, you might say, oh, this is so simple, I can do them. And then you get into the really challenging ones, and you're saying, I don't know what's going on here. The reason that happens a lot of the time in maths is because you need to spend more time practicing these. So it is important to practice these. Okay, now we're going to look at this number 8. And some 8 is slightly trickier because we're dealing with these negatives now. And when working with these negatives, if I had to expand this for number 8, right, I would then have negative x to the power 3 times negative x to the power 3 times negative x to the power 2 times negative x to the power 2 times negative x to the power 2. And then if we look at this question here, let's group these up. So we'll use this highlighter here. If we're looking at just this part here, so just these two terms, let's take them in terms of 2 and then 3. So we'll work with this part here, and then we'll work on this other section right here, which will be this. Okay, and they all be multiplied by each other. So if I went and looked at this, it will then become positive x to the power 6. And then here I'm going to put this times, and I have a negative times a negative times a negative, which will be a negative. And now if we add each of these exponents, so I multiply like basis, I add the exponents, negative x to the power 6, and I'm going to get negative x to the power 12. So when you're working with these negatives, you got to think about it like this. If I got a negative times a negative, it's then going to become a positive when I'm multiplying it by this, the exponent outside the bracket. And the same thing is going to apply for these other ones. Now let's look at 9 right here. Now when looking at 9, we have this, and so we're going to have 2 to the power, to the x to the power 8 times 4 x to the power 8. And then we can rewrite that as 2x to the 8. You could have skipped the step, times 4x to the 8. Now, because I have a multiplication, I can just multiply these. 4 times 2 is 8. X, because I'm multiplying like bases, I can add the exponents, and I'm going to have a 16 here. I hope this is all making sense to you guys. Moving on to 11. So we're going to take this in sections, and we're going to look with the brackets first. As always, you've got to think in terms of BODMAS, so we're going to sort out our brackets first. So I'm going to write 3 into negative 2 squared will now become 4. A to the power 6. Okay, minus 2, open brackets. I have a negative there, it's going to be to the power 3. So whenever you have a negative to the odd power, then it's going to stay a negative. If you have a negative number to an even power, it's going to become positive. So here I have a negative to a odd power. So it's going to stay a negative. So we have negative 3 to the power 3 is 27. No, yes, 27. A to the 6. And then now that will become 12. A to the 6. And so now I'm going to have, if you look here, a negative times a negative. So a negative times a negative is going to become a positive. 54 a to the power 6. These both have the same exponents. They're basically like terms. So it can then become 70 a to the power 6. Time to move on to this final one here. So looking at number 13 here, we're going to do the brackets first like what we did the last time. So we have 3 open brackets. We have negative 2 to the power 2, so it's going to be a positive 4a to the power 6, okay, times 2 into negative 27a to the power 6, and that's then going to equal 12a to the power 6 times negative 54a to the power 6. Weird sound. Okay, then you can then put this into your calculator, the 12 times negative 54. And let me just grab my calculator quickly. So I have 12 times negative 54 which is negative 648 a to the power 12. Great. Another thing about fractions is we will be working on negative exponents. Now, if you have a negative exponent, it basically means that, let's just look at this, okay? We have x over y. Now, let's say this x was to the power negative 1. What will that then mean is this x is going to flip onto this side because it has a negative exponent. So it's now going to become 1 over y times x. Or if we had an actual number, if I had 2 to the power negative 1, it equals a half. Okay? Another example of this is if I were to have, let's say, 1 over 2 to the negative 1, now this 2 is going to flip to the top and we're going to multiply it. So I'm going to have 2 times 1 on the top, and that's just going to equal 2. So I hope you guys understand that about negatives, negative exponents. This first question dealing with the fractions. And in this question here, we're going to square the top term and the bottom term. So I'm going to have, it's going to equal a to the 8 over b to the 12. And this was 1. So let's do 2 over here. And since we're dealing with 2, let's highlight 2. So in question 2, 10 to the power 3 is 10 times 10 times 10, which is going to be 1,000. Now, you can also work within the brackets first and simplify. So let's try doing that. That's how I tackle the sum here. So I have 10 over 5. That there can be simplified to a 2 on my top part. And then I have x to the power 3 over x. That's just going to become an x squared. Y over y squared. This is going to be over y. And then now I'm going to have this to the power 3. Can you see how much easier this is to work with instead of working with 1,000, for example? Now I'll have 2 to the power 3, which is going to be 8. X to the power 2 times this 3 is going to be x to the 6 over y to 3. Now working on this question here, we're going to use the same principle again for 3. Alright? So I'm going to open this bracket. What can I simplify? I can simplify this negative 2 over 2, and I'm going to get negative 2 in my denominator. I have p to the minus 6 in the bottom, if I bring that to the top, it's going to be p to the power 4 times p to the power 6. Okay, and this q to the minus 2 is now going to come to the bottom. So I'm going to have q to the power 2, and all of this is going to be to the power 3. Now I can still simplify these p's slightly because I'm multiplying like bases. I can add the exponents. So I'm going to have p to the power 10, and all of this is going to be to the power 3. So I'm going to have p to the power 10, negative 2 q to the power 2, and then finally my answer is going to be p to the 30 over negative 8 q to the power 6. Here I have this whole question to the power of negative 2, but let's not change our process. Okay, so now our process, we're going to simplify within the brackets first. So I'm going to have 3 over 9, I'm just going to have 3 here. So I'm going to have x to the 7 times x to the power 5. And now, since after simplifying, there's no numbers or variables on top, it's going to be over, there's going to be a 1 on the top. And then I'm going to have this to the power negative 2. Now there's still a bit of simplification I can do here, and then there will become 3 to the x to the 12. I'm multiplying like bases. I can add the exponents. That's now to the minus 2. Now, if you remember when I was explaining working on negative exponents earlier and what we did in our previous sums, you're going to swap. So when we're swapping here, we're going to swap both these terms. So we're going to be doing this because it's been applied to the whole fraction. And then here I'm now going to have 3 to the power to the x to the power 12 over 1 all squared. Now then 1, you don't really have to put it down. I'm just showing you guys so you can understand the concept. And then finally our last answer is going to be 9x to the power 24. This one was slightly different because it had that negative exponent, but I hope you guys understand what I did here. Please leave a comment below if you're still finding it tricky. Now let's deal with this question 5. Okay, if looking at question 5, we're going to do the same thing we were doing before, where we're going to simplify within the brackets first. So let's look at our numerator here. And I have 2a to the power 3 times 4a to the power 2. I'm multiplying like bases. I can add the exponents. So I'm going to have 8a to the power 5 over 8a to the negative 6. And this is all going to be to the power 2. So I can then now, we know that this 8 here is going to cancel out with this 8 here. And this a to the minus 6 is going to come here to the top. So I'm now going to have a to the power 5 times a to the power 6 all squared. And that's going to give me a to the 11 all squared, which is then give me a to the 22. Working with this question 6, right, it's a bit different, this one. So let's first start off by working within our bracket. And if I work within my bracket here, on the top I have 2 like terms, so I can add them up. Okay, and the bottom I'll have x to the power 4, and now this whole, all of it is squared. I can now cancel off these x's or work with these x's because 2 like bases and I'm dividing, I can subtract the exponents. But now when subtracting the exponents, what you should ask yourself, which exponent is higher here? And that's this 4. So if you look here, this exponent of 4 is bigger than this exponent of 2. And for that reason, as a shortcut, what we'll do is we'll just subtract it in the bottom. So I'm going to have 2 here, make my bracket properly, over x to the 4 minus this 2. This is all going to be squared. And then I'm going to have 2 over x to the 2, all to the power 2. And that is going to leave me, and that is now going to leave me with 4 over x to the power 4. Okay. Now going on to question 7. And now the whole question isn't in brackets. So we're going to work with our top first and then our bottom. And now I have, looking at this top part here, this is going to be x to the negative 6 times y to the 10 over x to the 3y to the negative 6. And that's then going to equal, so we're going to bring this x to the negative 6 here to the bottom, and we're going to bring this y to the negative 6 here to the top. So on our top, we're going to have y to the power 10 times y to the power 6 all over x to the power 3 times x to the power 6. And we're just going to simplify this, which will make it look like y to the power 16 over x to the power 9, I believe. And just like that, you have the question right. Now looking at question 8. So in question 8, it's similar to this question 7 we were dealing with. And we're going to keep this 3 onto the outside. We're going to open this. Now, negative 1 times negative 3 is going to be positive 4. And then positive 2 times negative 3 is going to be negative 6. And then all of this is going to be multiplied by a to the negative 5, b to the negative 5. And this is going to be over. So we're going to look at our bottom now. It is better to work with this in sections. Don't work with everything at one time. So I worked with the first section, then I got to my multiplication, I worked to the second section, and now I'm going to the bottom and I'm going to work with that section. So negative 3 squared is going to be 9, and then I'm going to have b to the negative 5 times 2 is negative 10. This will then equal 3a to the power 4 times b to the minus 6 times a to the minus 5 times b to the minus 5 over 9b to the minus 10. Now things are looking a bit complicated here because we have a lot of negatives, but let's simplify this top section because we have like bases. And I'm going to have 4 minus 5 is a to the minus 1. And I'm going to have b minus 6 minus 5 is going to be b to the negative 11 over 9 b to the minus 10. So now we get into our final steps here. Let's swap what needs to be swapped. So this b is going to come down here. This b is going to go up here. And then this a is going to come down here. So you need to do all of those. You can use a different color pen or something if that helps you to know what's going where. So now I'm going to have 3 and this 9. And b to the 10 is going to be on the top. And then a and then b to the 11. Now we can just do our simplification. So with this, the 3 and the 9, I'm going to have a 3 in my denominator. This a is going to be here. Then 11 minus 10 is just going to be b to the power 1. And I'm just going to have 1 over this whole question. Moving on to our final question for this section. So when dealing with 9, I have x plus y over x to the minus 1 plus y to the minus 1. I really recommend you trying this before I do it, because it'll really help you if you can start getting into this thinking. So we can't do much at the top. They're unlike terms. Pause the video now before I start explaining how to do the question. And x to the minus 1 can be written as 1 over x, like what I showed you earlier, plus y can be written as 1 over y. What I like to do with questions like this, where there's a division sign and then another division on the bottom, is I like to bracket the numerator and then put my division sign here and then bracket my denominator. So it becomes easier to work with and less clunky on your page, which will avoid errors. So this x plus y, we still can't do anything about it right now. We can't do anything about this division, but we can add these two terms. So we're going to find a lowest common denominator, and that's going to be xy. And then we're going to have y plus x here. Then what you're going to do is, when you're dividing, you can do what is called the reciprocal. So I'll have x plus y, okay, and if I do the reciprocal, I can multiply it by swapping both these terms. And then now what I'd be left with is xy over x plus y. Now this x plus y is over 1. And if I look at these terms, I can then see that this x plus y cancels out with this x plus y, and then I'll be left with x, y. And that's your final answer. Hope this video is really helpful. Leave a like, comment, subscribe. And if you'd like more videos, please let me know. Please let me know how I can make the content more engaging and better for you guys. Thank you.